That's good.
So this is what I can do for Yahya. So all right. So this recording is also available. Inshallah Ta'ala, I'll share the link. Okay. With
Okay.
Yahya as well so that he can get it. All right. So
Okay.
in the last couple of classes, we have so far we covered energy. Yes, we started off with the energy. Okay. And energy transfers takes place, how the energy transfer takes place, and what is useful energy, what devices, how do they work, what is the input energy, what is the output energy, and what is the store form of energy and transfer, what is thermal energy, form of energy which refers the total energy of particles, what is temperature, that is the degree of hotness and coldness of a body, which refers the average kinetic energy of particles. Heating always increase the internal energy of the body. Um, and then we also went through the chemical energy and nuclear energy. And then what the two type of reactions we studied, nuclear fission and fusion. So the fission is large nucleus splits into smaller, and the fusion is a smaller nuclei join or combine to make larger nucleus. And this fusion actually happens in the formation of star, right? In the formation, sorry, in the formation of star. Um, and then we also did some questions, how the different process takes place, like burning of coal. It starts from the chemical energy and it ends up to electrical energy. And hydroelectric generations, like gravitational, from the gravitational potential energy, it goes to kinetic and electrical, and windmills and nuclear powers generation and solar energy. So this is how these all things work. We also discussed about the work done. If any object, is applied by external force. So if it is moving, so the work is done, right, to displace the body from one point to another point. That means work is done on that body. The formula of the work done is force times distance, or we say displacement or distance traveled in the direction of force. And after that, a person is knocking the nail into the wooden block with the hammer. How the energy transfer takes place? A person is working. The energy is stored in the person, that is in the chemical energy, right? That is in the form of chemical energy inside the body of the person, right? So that energy transfers to the kinetic energy because he is moving his hand, right? While hitting with the hammer, and due to the movement of the hammer when it hits the wooden block, so a sound and the heat is produced. What is work done? I have already spoke about this. And then we also talked about the renewable and non-renewable energies. Source of energy which is infinite and never runs out, so like wind, tidal, geothermal, hydroelectric, and solar. um, Likewise, you can see here a source of energy which is limited, finite, and cannot be replaced easily. So you can see here what could be the examples of non-renewable energy sources. And we also talk about the efficiency. Efficiency is the ratio of the useful energy output to the total energy input, or we can say total energy output, right? So instead of writing total energy input, we can write total energy output as well. After that, we also went through the Sankey diagram that tells the flow of the energy from the input to the output, and whatever the wasted energy that we do not want. Wasted energy is the energy that we do not want. So it is shown, it is represented like this curve, root. Okay. So this is all about that we did in the syllabus coverage session one. And now we're going to talk about the session two, that what we did. We started off with the density concept of density. Density is actually, that refers how much mass is there, how much mass is there or concentrated or packed into a given volume of a substance or a body. So density depends on the type of the material. That means if one type of material, if different objects are there, but all the objects are of the same material, so the density of each, the different shapes of the objects are placed. So the density of all the objects will remain be same. Why? Because they all are made up of same material. If the material changes, then density would be different, right? So now we also spoke about the density does not depend on the shape or size. So this is how we come up with the conclusion that actually density is mass per unit volume. If you have the mass of any object, if you have taken the volume of that object, you divide them, you'll get the density. And the symbol for the density is this. We call it rho, right? Now, a substance that has high density, so will have a lot of mass in a small volume. And if I say there is a low density, so I will say that it will have less mass spread out over the same volume, right? Now, if I take an example, I have the two containers, the both containers having the same volume, right? So now the substance that are is placed between these two container in inside these two containers. So the large stones of calcium carbonate and the small pieces of powder form of calcium carbonate are placed in inside these two containers. So what we are observing here, which one is going to be denser? A is less dense. Why? Because the air particles, you can see here, I have shaded some of the spaces with this pink color. That shows the air particles are, occupying these vacant spaces, right? So the large stones of calcium carbonate, A is less dense. Why? Because it has a large pieces of calcium carbonate kept inside this container A. So air particles can occupy, can enter, and causing it to be less dense, right? Uh, I also spoke about the needle. A needle sinks in the water as the density of the needle is higher than density of water. Density of water is about 1.0 gram per centimeter cube. How the boats and ships are designed to float over the water. They are designed hollow so that the air, can occupy the space inside that ship or boat to make its average density less than the density of water. So this is how the objects are designed to be made less dense, so that the load can be contained by the ship. The people can be accommodated over there. So if they cross the limit, definitely what will happen, the density increases and the average density increases, and the ship or the boat can sink, right? If the number of people increases, right? Okay, if large number of people, accommodate in the ship, and the less air will be there. So what will happen? The boat or the ship can sink. Um, we also spoke about the measurement of mass, because since we know that density is actually the mass per unit volume, so we should know that how to calculate the mass, right? So the amount of matter that is present in the body at rest relative to an observer. So people, most of the times the student already know how to measure the mass, so I'm not going to talk in detail. We have already gone through this as well. um, then we talk about the volume. Again, volume is can be calculated if there's a regular shape object. That means it can be the formula can be applied on that object, right? If you multiply three sides, so you'll get the volume. But what if I have irregular shape object? So how will you measure the volume of that irregular shape object? So what you need is you have to follow the displacement method, that is also known as water displacement method, where you take the volume, you take the measuring cylinder, you fill the measuring cylinder up to the mark, partially or half of the measuring cylinder is to be filled by the water, and then what you do is you will immerse that gently immerse the irregular shaped object inside the measuring cylinder, right? So what will happen? The volume will rise. Volume will rise. So whatever the change of the volume that you observe, right? Whatever the change of the volume that you observe, so that change will be equal to the volume of the irregular shaped object, right? Now, after that, we talk about if the object cannot fit in the measuring cylinder, right? So what do we have to use? We have to use this displacement can, which is also known as Eureka can, right? Clear? Now what we do is you can link with the measuring cylinder. We will fill this Eureka can first, and then we will wait until the water stops coming out from this outlet. Okay, and then when the water stops coming out from here, then we will immerse this irregular shape object, right? Then what will happen? The level of the water rises and it will be collected in the measuring cylinder, right? So whatever the volume that is collected in the measuring cylinder will be considered as the volume of the irregular shape object. Then we started off with the pressure. Pressure is force per unit area. When you apply force, right, to any object, so what happens? That force causes the pressure. So if the force is greater, there will be greater pressure, right, keeping the area same. And if there's less force, so definitely the pressure will also be less. Second thing, if you make the area broader, area in contact broader, so what will happen? The pressure, decreases. How does this thing happen? I'm going to talk about that, and then we will start from here. Okay. Now I gave you this example. Did you get this point clear in the last class? What uh, what
Yeah.
was discussing about this object that I took, and I gave you dimensions of this object, and I asked you to find out the maximum and minimum pressure. So what idea do you think that we are going to apply here?
Uh, we find the area of the to find the maximum pressure. We find the area with this. We find the side of the smallest area.
Yeah, so this means that we are going to apply the concept of area. In order to have the maximum pressure, I have to have the lesser area, right? Because the area in contact with the ground, okay, will give you the greater pressure or will give you maximum pressure. So now, since you know that it's a 3D figure, just give me a second. All right, so we're gonna talk about so what I was saying. Okay, so different, sides will give you different pressure, right? So let me do it. Uh, okay, now, so this side, this side is giving you. Why it is not working? Yeah, this side is giving you the area 8 centimeter square, right? So what is the mass? What is the mass that I have? That is 100 kilogram. I need to convert this 100 kilogram into Newton. Uh, for simplicity, for my easiness, I'm taking the strength of gravity 10 Newton, okay, per kilogram. Now, in order to convert this mass into weight, I will be using this formula, mass times strength of gravity. So I'll multiply 100 times 10. Okay, so it becomes 1000 Newton, right? Okay, now this
Yeah.
side is giving what pressure? We're going to talk about that. Pressure is force per unit area, or we can say the weight upon area. So the weight that I have is 1000 Newton, and the area that is in contact is going to be 8. So if you divide this, could you please tell me the value? What answer are you getting? And now if I take this area, if I take this one,
128.
38,
Well, 125. Sorry.
135
One,
Newton,
125. 125.
125 Newton upon centimeter square. Is this clear now? So this
Yeah.
is how we calculate pressure. Now, second thing, we have this phase as well. When the object is in contact from this side, an object is in contact with this side. So which area is in contact? What is the value of the area? That is 12
Well,
centimeters square,
yeah.
right? So uh, over here, again, we are going to use the same formula for weight upon area. Weight is going to be same, okay, divided by uh 3 times 4 is going to be 12. So you divide 1000 by 12. What answer are you getting? Please tell me.
83.3.
Yes,
83.3.
83.3 Newton per centimeter square. Now, here's another side which can be in contact when we take this side 2 times 3 1, right? So 2 times 3 1, we get 6 centimeter square. So what pressure will we face? 1000 divided by this 6. So what answer are you getting? It's going to be around 160,
166.67.
166.7 Newton per centimeter square. Now, what are you getting from these three pressure? What is the minimum pressure and what's the maximum pressure? The maximum is going to be 166, right? So this is going to be your maximum pressure, right? And this is going to be your minimum pressure, right? Now, if you
Assalamualaikum.
can, Walaikum Assalam, Moss. If you can see here that the weight is kept constant here, right? But the area in contact is different from different sides, right? So which one is giving you the minimum pressure? When we take the maximum, when we take the greatest area, when we take the greatest area in contact, will give you the least pressure, right? Okay, this one is the least pressure. Least pressure. And if you take the smallest area, if you take the smallest area, so you will have the greatest pressure. Now, what relation between the area in contact and the pressure have you understood? Yes. What relation have you understood?
There's a bigger area, the pressure is less.
Yes. So the thing is that if the area in contact increases, if area in contact is increased, if if the if the area in contact increases, the pressure decreases, keeping what same? What we have taken same? Weight, okay? keeping the force same. I hope that this point is clear. Or if we say that um, if the force increases, the pressure increases, keeping what same? Keeping the area in context same. Keeping the area in contact same. So I hope that these points are clear to you, right? Okay, so now we're going to talk about the uh, pressure in liquids, right? How pressure is exerted in liquid. So what do you think when the diver experiences pressure from the seawater? Yes. Does diver
Um,
experience does diver
yeah,
experience the pressure from the seawater if he dives? Yeah.
yeah,
And the deeper he goes, and deeper the diver goes and dives, the greater pressure will he exert, or he face, right? So why he will
yeah,
face the greatest pressure? So um, we have learned, right? We have learned this concept that actually pressure is the force per unit area, right? So what happens? Force acting on the diver is actually due to what? Due to the weight, right? So let's take an example. We know that pressure is force per unit area, right? And the formula for pressure is force per area, right? Okay. Now, what happens is uh when the the force on the diver when he dives into the sea water. So the force on the diver is exerted due to the weight of the sea water, weight of the sea water, right? And pushing down on the diver, right? Clear?
Yeah.
So what happens when the diver goes down and deeper? When when he goes deeper and deeper, so the more, more water, sorry, more water above the diver, above the diver comes, exerts, what? Exerts greater force, right? Exerts greater force. Hence, what happens? Hence, the pressure increases. Now, let me illustrate here with one example. If this is a block or object, and if I say that here are One, two, three, four, five. Five particles, right? And on the same object, right? That is kept aside. And one, two, three, four, five, six, seven, eight. So these eight particles will make greater force together, right? And these five particles will make force lesser together on the block, right? Okay. Now, if I say these are the water particles, if I say these are the water particles, okay, and these are also water particles. So as we go deeper and deeper from the surface, if this is the, the level of the water, right? And this is the level of the water, clear? Now, what are you observing here? If you are far from the level of, if you are far or deeper from the level of the, surface of the water, so the more force will be exerted on the body, right? More force will be exerted. Why? Because more water will be there. Is this clear to everyone? More water is there. Yeah.
Yeah.
So more water will be above the object, above the diver, or any object is there inside the water. So the more force, and more due to more force, more pressure will be exerted. Clear? So
Yeah.
how does depth affect pressure in a liquid? I have spoke about that. So if I take this example, if I have this container, right? And this container has different, you can say, outlets, right? Let me make it same size so that you should not should not get confused. Now you can see here I have taken this, and this is the, let's say this is the level of the water. Okay. Now let me make it more high, so that the distance should be noticeable. Now this distance, say this distance is d1, say this distance is d2, say this distance is d3. Clear? Right?
Yeah.
So this distance is d3. Since you know that d3 is the height, okay, or distance, uh greatest, right, from the from the surface of water, right? Yeah. So
Yeah.
Yeah.
what do you think, where will this water go? This one, say this is outlet A, say this is B, and say this is C. So A will throw the water, most away from the container. The B will reach this point, and the C will reach to this point. So why the A is throwing the water most away from the container? Why the most distance is traveled by the water that is coming out from the point A?
Because point A has the greatest pressure.
Pressure. And why the pressure is greatest at point A? Because the height is greatest, right? Clear?
Yeah.
Okay, so the water spurts out furthest and fastest from the bottom hole. Remember this thing, okay? So the water spurts out furthest and fastest, right? From the bottom hole. Clear? And so this shows, what does this show? What does this show? This shows that the pressure, we have already understood this concept. So this shows that The pressure is greatest. Pressure is greatest at the bottom of the container. Right? Okay.
Yeah.
Now, is there anything that affects the pressure of the liquid? That thing is, what do you think if I have a water in one container, I have a water, and in one container I have um, a viscous liquid, a thicky liquid. Will the pressure be same if I cover the same height?
No.
No. So that means a density, how density affects the pressure, right? So we're going to talk about density, that pressure in a liquid increases with depth and increases with the density. Clear? So there are two factors. Uh, you by increasing those two factors, pressure in a liquid increases if you increase the depth, okay, and if you increase the density. So after 9 minutes, inshallah, we are going to start the class again. Clear? And you people have to join.
Okay.